Okay, ma'am. So, good evening, everyone. I'm Amruta, and it is my absolute pleasure to extend a warm welcome to all of our participants on this day three of 2 week short term program on AI and ML coding using generative AI, which is powered by Indian Science Technology and Engineering Facilities MAP. So, this program is being conducted from 24th March and till April 4th. So, we are delighted to have you all on this exciting journey. So, before we begin, here are some important guidelines to make sure the smooth and effective session. So while joining, please share your name and affiliation in the live chat. Use a laptop for better experience and especially during a hands-on activities with our experts. Filling up the feedback form during each session is compulsory. So this form link will be shared in the YouTube chat box. So let me take a moment and introduce Academy Innova World. Academy InnovaWorld is dedicated to fostering interdisciplinary learning and research through advanced training programs, webinars, workshops, and different types of industrial collaborations. So, our mission is to bridge a gap between theoretical knowledge and practical implementation, empowering learners to excel in emerging technological domains. So it's an honor to welcome our Chief Technology Officer, Pulak Kumar Dhara, and distinguished technologist, a former assistant scientist of a Department of Atomic Energy. His expertise and contribution in research and development have been shaping our organization's vision and growth. I also extend a heartfelt welcome to our esteemed guest for today's session, Dr. Arunava Majumdar. We are grateful for his presence and look forward to his valuable insights as he takes over today's session. Wishing you a great learning experience. And with that, let us move ahead with today's session. I hope you all have a productive and enriching learning experience. Over to Dr. Arunava, sir.
So good evening, everyone. So welcome you all in day three of the hands-on experience and the new learning experience through the hands-on practice on and through the generative AI and the experience of coding through generative AI. So in the last class, we have talked about the means different kind of ML models, like what regression is, what classification is, okay, and how the ChatGPT can generate different data sets, and how through ChatGPT we can generate different plottings, statistical plottings, and also the regression plotting, histograms, scatter plot regression line. So these kind of things we have already discussed, and all kind of descriptive statistics also we have discussed, right? So today we will talk about the overview of regression. That is how regression models are created, and what is the classification and regression models are basically created in general, means theoretically created, and how we can generate the modeling and the results through ChatGPT, how we can generate the code, so that when our data limit is finished in ChatGPT, and we can generate the code to use in some other platform to generate our results. Okay, so let's start with what regression is and what regression modeling is. Last class we have, okay, first let me share my screen. Is it visible? Okay. The last class we have discussed about the correlation coefficient, correlation coefficient, just using a very short form to just reduce the time. We also have discussed about the scatter plot. Okay, today we will discuss about linear regression. And linear regression, first of all, it is a method, it is a purely statistical method. Also, we use this as a part of machine learning, but basically, linear regression is a method of statistics to analyze the data to make a model. Okay, to linear regression, it is a prediction model. Okay, so what prediction model is, let us suppose I am considering a data set. Just I am giving you the example of only two data sets, X and Y. Let us suppose that X, it defines some temperature, and Y defines its a rainfall. So when now we just consider some data set arbitrarily, temperature, let us suppose when 30-degree, rainfall maybe 20 mm, similarly 35, 25, um, 20, 22, 25, 21, uh, and so on. So we need to already we have I explained that we can make a we can predict a relationship between X and Y dataset by using the correlation coefficient. And correlation coefficient value, it varies from -1 to +1. If it is -1, we say negatively correlated, +1, positively correlated, 0 or very near equal to 0, then we say no relation between them. Now I will make a model which predicts that for any unknown temperature, let us suppose the temperature is 30, 35, 20, and 25. 15 is not in the table. Okay, so if the temperature is 15 degrees centigrade, what should be the amount of rainfall? I want to predict this one. Then how can I predict it? Then linear regression will be helpful in this case. But before starting the linear regression, I'm not going to get deep into the mathematics and statistics. Okay, just for an overview, I'm saying that linear regression not applicable for all kind of data sets. Linear regression is applicable for the linear type of data sets only. And what linear type of data sets? If I draw the scatter plot of this data, our first point is 30-20. When it was 30-20 is, suppose this point, this is 30-20. Our second point is 35-25, 35-25, maybe like this, 20-22, 20-22, maybe like this, 25-21, like this. And suppose the other points are this. This is our scatter plot. Now, in this scatter plot, I already told you that if this scatter plot, the trend of the plotting, it is upside, it means we can say that there is a positive relation. That is, if the temperature is high, then there may be a chances of high rainfall also. Positive relation. Now, in case of modeling purpose, we have to draw a straight line for linear regression. We have to draw a straight line like this. Okay, we can say it is a based fit line. Based fit line. How this based fit line is drawn? Based fit line can be drawn by using the some statistical mathematical method. The least square approximation is there. Okay, by using which we can draw this line. But I'm not going to describe all these things because it's a hands-on experience class. So this line, now we know that each and every straight line have an equation like y equal to mx plus c. Okay, so m is the slope of the straight line and c is the intercept part or constant term. So this straight line will also having some equation like this: y equal to mx plus c. Let us suppose y equal to 3x plus 2. This is the equation of the straight line, the best fit line equation. If we get the equation of the straight line, now we can easily predict the value of the rainfall. Now we just need to put, we need the temperature 15 degrees centigrade. At 15 degrees centigrade, sorry, yes, centigrade, what is the amount of rainfall? So we just put 15 in place of x. So y equal to 3 into 15 plus 2. So 30 plus 2 is equal to 32. Okay, but 15 degrees should be the less amount of rainfall, not 32. I'm just giving you an example. Of course, the straight line, this should not be the straight line. It's just for the sake of example I'm giving you. So we can predict the amount of rainfall. This is called the predictive modeling by using linear regression. But this is only possible. There are three conditions of the linear regressions. If those conditions are satisfied, then we can say that yes, the linear regression uh, is possible in this kind of data sets. Okay, so I'm not going to describe all of these things because that is a deep mathematical thought. Okay, one of the condition of the data set. Okay, so I will let you means explain this later. Next one, now I told you that not all kind of data set linear regression will be the best. Okay, if the scatter plot is like this, if the scatter plot is like this, of course, if we draw a straight line, it should be looking like this one, and which may not be a best fit for this. In this case, instead of drawing a straight line, we can draw a curve like that. This curve, it may be a of degree 2, polynomial of degree 2, it means the parabola. Okay, and the equation of parabola, y equal to ax square plus bx plus c, the general equation. It means straight line means linear equation. The power of x is 1, and polynomial of degree 2, it's a parabolic line, parabolic curve, ax square plus bx plus c type of equation. So in this case, maybe this particular parabolic equation should be the best fit for that. So the modeling will be much more appropriate. Okay, so this is called the predictive modeling. Now I am giving a very simple example of the linear regression with just two data sets. Now the question is, can linear regression applicable for multiple attributes or multiple columns? Answer is yes. Linear regression, is also applicable for multiple columns. We say this multilinear regression. An example, suppose we are having three different columns x, y, and z. X is temperature, y is humidity, Z is rainfall, amount of rainfall. So we want to predict Z, the amount of rainfall, which is our target variable. Now you see our independent variables or feature variables, it is increased 1, 2, and the Z is the target variables. And for different data now, can we draw the scatter plot? Yes. Till now we can draw the scatter plot, and that will be the three-dimensional scatter plot. Z will be the horizontal axis, X will be the one of the vertical axis, and Y will be another vertical axis. And these three will, let us suppose this 10, 10, 20, 12, 15, 25, 13, 15, 26. These 3 points, okay, will represent here. So this is, let us suppose this is 10 comma 10 comma 20, and similarly the other points are like that. So it is a three-dimensional Euclidean space where we draw the points, and which is a 3D scatter plot. Can we draw the straight line? Yes, we can also draw the straight line here like this, which is a 3D line but drawn in a three-dimensional Euclidean space. Not two-dimensional, but it is also a straight line. And how the straight line can be represented here in this case? Here we represent like this: Z equal to A plus B into X plus C into Y. This will be the linear model for three-dimensional scatter plot. Now, what is the difference between the previous linear regression? When it is two dimension, only X and Y. X is the prediction variable, Y is the independent variable. Okay, our straight line will be Y equal to A plus B into X. In case of two dependent variables X, Y, and Z, two dependent, one independent, we will write Z equal to A plus Bx plus Cy. Now question is, can we increase the number of variables? Yes, of course we can increase the number of variables. Let us suppose x1, x2, x3, x4, and uh, z. All x1, x2, x3, x4 are independent, and z is the dependent variables. Now, can we draw now suppose 10, 10, 20, 20, the amount of rainfall is 35. Now x1, let us suppose it is temperature, x2 humidity, x3 velocity of wind, x4 let us suppose it is AQI or air quality index. Okay, so for this data set, now can we draw a scatter plot here? No, now it is not possible, because visualization, when maximum three dimension we can visualize, 4D or 5D or more than, when we increase the dimension, we can't visualize this, but we can make the model. Now in this case, what should be the type of linear equation? It should be Z equal to A plus Bx1 plus Cx2 plus Dx3 plus E into x4. Now here A, B, C, all this, you can see these coefficients, not this one, this is called intercept. Now these are the coefficients of these variables. Okay, if we we can obtain these coefficients, the value of these coefficients, we can easily predict what should be the value of z for any random values of x1, x2, x3, and x4. But condition given, data must follow the linear trend or the linear relationship. Otherwise, linear relation or linear model may not be the best fit for all the cases. I think you can get it now. So linear, now just before starting the coding in ChatGPT and the other examples in ChatGPT. Let me explain an example so that it will be much more clear to you. Let us suppose I'm considering a data set x1, x2, x3, x4, and y. Okay, 10, 10, 20, 15, 10, 25, 10, 20, 14, 12, and so on. This is our prediction. This is our prediction, and these are the uh, features. These are the features. Okay. Now let us suppose we are creating a linear equation, linear relationship. So after the modeling, we get y equal to 2 plus x1 plus 2x2 plus x3 plus 3x4. Okay. Now suppose for any random values of this data, let us suppose 1, 5, 5, 10. Okay, I want everybody to um, write down the answer. What is the value of y? My question is. This is the prediction model. Okay, now I am putting as an user, I'm putting the values of x1 as 1, x2 5, x3 5, and x4 as 10. And what should be the prediction of y? Okay, I want everyone to please write down the answer in the YouTube chat box. I'm giving you just 1 minute to write down the answer in the chat box. Then I will proceed for the next level. Yes, yes. Uh, that is nonlinear equation. Okay, ax plus bx plus cy, it is linear equation. Ax, if I write down the square, okay, it should be the nonlinear, not a linear regression. That should be a nonlinear polynomial regression. Okay, so we can't write that one. For polynomial fitting, we can use that one, but not here. Yes, I think I can get the answers. 48. Okay, so it means that if I put the any values of 1, 5, 5, 10, then we need to write means our prediction should be 48. Okay, now I think you can get it what linear regression is and what multilinear regression is. Now another question is also there. Can we consider more than one dependent variable? That is like this: x1, x2, x3, x4, and also y1, y2, y3. These are the features independent variables, and these are dependent. Is it possible? Answer is yes. This is also possible. Okay, in this case, we can do two things. One thing is, let us consider the example 10, 10, 20, 15, and y1, y2, y3, that is 1, 1, 5, 25, 10, 20, 14. 2, 1, 3, 10, 15, 16, 16, 5, 3, 2, and so on. Now this is our data set. Okay, two things we can do. First of all, depending on the nature of the data, if we have to show means calculate the correlation coefficient between the variables on y1, y2, and y3. It means that we have to create a correlation matrix. Okay, so y1, y2, y3, y1, y2, y3. So of course y1, y1 correlation should be 1. What is the correlation of y1, y2? What is the correlation of y1, y3? What is the y2, y1? Y1, y2 and y2, y1 are same. Okay, so I'm not writing this one and this. So this correlation matrix, basically correlation matrix, it should be symmetric. So that is why I'm not writing this lower triangular area. Just these three values are enough to represent. So these values, if the correlation coefficient between these dependent variables are very low, okay, and they are not related to each other, then what we can do, we can separately predict the models, means make the prediction. Okay, so we can go for three different equations: y1 equal to a plus bx1 plus c x2 plus dx3 plus ex4, y2 equal to a plus the sorry, this a1 b1 c1 d1 e1 is a2 b2x, and this one, and y3 equal to this. So three different models we can create if we can confirm that the correlation coefficient between x1 x y1 y2 and y3 is very low. But what happens if the correlation coefficient, because they are very much highly correlated between them, in that case we can go for dimensionality reduction. Dimensionality reduction. So what dimensionality reduction is? Dimensionality reduction, these three variables are merged together and we will create a new variable y or y dash or whatever name you want, you can give, that will represent only single variable on behalf of these three variables. Okay, and we will get some single values, suppose this is 2, 3, 5. Okay, by using some substitution formula and some methods, there are many methods are there. Okay, so dimensionality reductions can be done by using several methods are there. One of the very important method is called PCA, principal component analysis. Principal component analysis. Okay, so with this method is using a very important and popular linear algebra concept, which is the eigenvalue. Okay, to reduce the dimension between these independent variables. Okay, so I'm not going to go deep into this because all these things we will, when we code it, all this kind of PCA and everything already available in Python coding and Python libraries. PCA library is there. So we need to use that simple function, PCA function, to reduce the dimension. So no need to worry about that. Now, uh, another question is also there. Yes, 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 yes. Mm. Mm. uh, Correlating with each other means, I don't understand this. Okay. I want you to please explain correlating means, I don't get it. Correlating can be data, two different data sets can be, correlation coefficient can be found, and we can say that positively or negatively correlated. Okay, y1 y2 they are the model. Okay, so two models are correlating. I means I'm just not getting this point actually, but actually um, uh, is actually meant to say. Okay, I don't think so. Means y1 y2 if they don't have the correlation between each other y1 y2 and y3, then we can get three different models for y1, for y2 and y3. Three different models can be created. Okay, if y1, y2 and y3, these three are having correlation between each other. Okay, yes. Also, we can do, let us suppose y1 and y2 is having high correlation between each other, but y3 does not have any correlation between y1 and y2. In that case, we can merge y1 and y2 only. Okay, y3 can be separated. Y3 can be entirely separated from that. Okay, so we can merge y1 and y2, so y dash and y3. So for these two variables, we can predict the models like that. Okay, now another question is, can the independent variables also can be merged, or we can reduce the dimension for independent variables also? Answer is yes. If we find very too much correlations between any two or any three of the independent variables, we can merge them, or we can reduce the dimension by merging x1 x2 or x1 x2 x3 by using the same PCA method. There are other methods are also available. Okay, I'm giving you just an example. Okay, so why we are doing this? Because correlation, if the independent variables are correlated between each other, our one of the conditions of the linear regression is the autocollinearity, that is correlation between the independent variables must be very small. They must not be related to each other. Okay, so that is why if their correlation coefficient between them is very high, just reduce the dimension by using PCA. Okay, so there are several methods are also there. I'm just giving examples. It depends on you what kind of method you may use so that your model will be accurate. Okay, now let's go to the programming thing, and let's go to the chat GPT now. Okay, let's go for a data set. Okay, I am providing the data set to the chat GPT and asking for uh, the linear regression. I'm starting with the two dimension only, that is x equal to uh, let's try for feature equal to okay, and target. Okay, uh, model with linear regression. Okay, now look at this. The model for, I have just given these two data sets. Okay, and the model is given each and every, what is the slope, what is the intercept. Okay, the constant part is called the intercept. Okay, since I have given only one feature here, 1 2 3 4 5, only one set of features. Okay, that is one set of independent variable, one dependent variable only. And for this is the model 4.5x plus 4.7. Okay, so you can say the predicted values for y equal to 1, y 9.2. Now look at this. There are some metrics how your model is performing. Now y equal to 4.5x plus 4.7. Does it model give, is it a good model or not? How can you predict it? These predictions, there are some metrics to find this. That is whether your model is good or not. One of the metrics is MAE, mean absolute error. Second one is MAC, mean squared error, root mean squared error, RMSE, and R square. These four matrices we use for regression modeling only, not for the classification. Classification is different metrics are there. So now look, now this is our model and these are our original value. So when x equal to 1, what is our original value of y? Originally the value should be 10, but according to our model, what is the value? If x equal to 1, y equal to 9.2, near equal to 10 but not exactly equal to 10. Now for x equal to 2, what is the actual value? 15. But what is here our model value? If I put x equal to 2 here, our model gives us 13.7, not equal. Okay, but it differs but not too much. Okay, now how can you predict that your model, sorry, how can you confirm that your model is the best fit or a good fit model? You have to calculate the MAC, mean square error for that. What is mean squared error and everything, what is the formula, I will describe you later. First, let me give you some other prompt. If we are giving more than one independent variables, then what happens? Let us suppose x1. Let us put it like this: feature x1, 1 2 3 4, just 1 2 3 4, x2, 10 20 30 56, and x3, 5 4 8 10. Okay, now go for the target. Let us consider only one target here, just y, 10 15 16 19. Okay, next we use the same prompt. We copy and paste here: model with linear regression. Okay, so ChatGPT is also using the same Python code actually. Behind this visualization, actually Python code is running to predict this modeling. Okay, now look at this: y equal to 3.95 x1 plus 0.2025 x2 minus 0.8, and this. Okay, so the parameters, so intercept, look at this 9.5, the constant term is called intercept, and the other things x1 x2 x3, the coefficients are written here. Okay, now if you use let us suppose I want to reduce the dimension using PCA and then want to predict the model. Okay, so I will not repeat the same question. Here you can see x1 x2 x3, three feature variables are there. Now what I want now, I want to reduce the dimension and I want to merge x1 and x2 by using PCA, reduce the dimension for x1 and x2. Okay, so I don't repeat the same question. I will just change the prompt now. Okay, reduce the dimension for x1 and x2 using PCA and make LR model. Sorry, LR means linear regression. Now let's see what happens. Look, so now x1 and x2 variables are merged and a new variable is created as xpca. It creates xpca. Now our model is also changed now. This is our model prediction now. So first it will apply PCA and combine x1 and x2 to form another variable xpca. Okay, and this is the model now. Is there any difference? Yes, there are a lot of difference between these two models. Okay, so PCA values, first we need to this table what we used here, x1, x2 and x3. So another new variable x3 will be produced and new values for x3 will also be produced, another 5 new values. So now our table will be xpca, x3. These two will be the feature variables and the target will be the same. Okay, so after reducing it, now we need to if I want to confirm, I want to just I want to confirm that which model is the good fit, best fit model, our previous one or after using the PCA. Just ask a chat GPT, which compare which one is better. Okay, now see. First, it calculates the mean squared error. I told you previously that we need to calculate the mean squared error and the R square value. So look at this MAC for original, that is without PCA. Our mean squared error is almost equal to 0. So 0.23 into 10 to the power minus 28. It means it is near equal to 0. Okay, and R square value is almost perfect fit, that is 1. Not one bit, maybe near equal to 1. It says 1. But with PCA, 1.23 is the mean squared error. So our mean squared error increases if I use PCA in this case. Okay, and R square value is 0.88. Also R square value reduced. Okay, so of course we can say the original model without using the PCA is the best fit model. So the original models preferably is the better. Also it gives the insights. Okay, now for your information, let me uh, uh, describe this one. R square value should be near equal to positive 1. Okay, basically R square value, it may sometimes in cases if our mean value, original values are less than mean, that is then R square value may be sometimes negative. So if the R square value goes to the negative side, we say that it is a underfitting model. Okay, so as if your model is good fit model or best fit model, of course R square value should be near equal to 1, very near equal to 1. But still R square itself cannot confirm the model is best fit. We also need to find out the mean square error. So if mean square error and R square both are, mean square error should be means near equal to 0, but R square value should be near equal to 1, positive 1. Okay, so if these two things means both are giving the results in positive way, that mean square is very less, R square is very near equal to 1, then we say that model is the best model. Okay, now before
Okay.
starting
Sir,
the
there,
programming,
sorry to
yes,
interrupt you. So meanwhile, we have some couple of things that I think if you can give the clarity, it will be better. One of the audience is asking, sir, can you please repeat the name of all the four matrices?
yes, naming the, okay, I'm writing the matrices. First one
Yeah.
is R
And one
square.
more thing is there, sir. One more question. Sir,
Yes,
can you tell me the application of PCA? This two major question we have.
can you please tell me the applications of
Application
PCA?
of PCA.
PCA.
Yeah. This two thing. And later part of the question we can take it in the after the winding up the session, sir. Right?
Okay, okay. Let me the check matrix for regression. For regression, to check whether our model is best fit or not, we need to calculate R square. Okay, then MSE. MSE means mean squared error. RMSE, basically MSE and RMSE are related to each other because we root mean square. Root mean squared error. Okay, so R square, MSE, RMSE, and another one is MAE, mean absolute error. Okay, so everyone please write this down. These are the matrices for regression purpose, not for classification purpose. Okay, should I go for the next question now? Okay, next question is the application of PCA. PCA, it means that when we need to reduce the dimension. Okay, reduce the dimension means, let us suppose there are many variables x1, x2, x3, x4, x5 like this. Okay, so two cases happens. One case is, let us suppose that the relation between x1, x2, x3, x4, x5, the relation between x1 and x2 is very high, means very highly correlated, very near to +1 or very near to -1, or the relation between x1 and x3 is very high. Okay, in that case, suppose these two variables, the relation or correlation coefficient between x1 and x2 is very high, what we can do, we will merge these two variables, we will create a new variable xpca. Rest of the other variables will be remain same. Okay, so it will reduce the dimension now. Previously it was 1 2 3 4 5 variables, now it is converted to 4 variables only. So PCA is used to reduce the dimension, but not all the cases we will use PCA. Just we see the previous example, if we use PCA, our model was not best fit model. Okay, so not all the cases, if the we will use, if there are too much variables are there. Okay, so for the reduction time complexity, to reduce the time complexity, we need to use sometimes the PCA. Or if the relation between the variables are very high, then also we can use PCA. Okay, I think it's clear now. Next, now I am going to show you for the platforms. Now, since we are going slowly moving to the programming languages, means Python coding and the other coding languages. So let me introduce you which platform you may use. First, the platform I suggest for Python coding. The platforms are Jupyter Notebook, freely, okay, freely available. If you're using MacBook, then you can run the Python there. But if you're not using MacBook, Jupyter Notebook is one of the best options. So let me write it down here. Jupyter Notebook. Okay, Jupyter Notebook is available online also. Okay, you can use directly use online through online, or you can download Anaconda. Okay, I suggest to download Anaconda because there are many other platforms are also available there. Third one, I can say it is the best one, VS Code, Visual Studio Code. I use VS Code, okay, because there are many features, and the I can reduce the time of writing the code in VS, because there are some AI features are there, okay, in VS Code. Okay, now let me show you how you can download this one, Jupyter Notebook. Introduce. Just simply you type here online Jupyter. Okay, online Jupyter. So you can see the Jupyter Notebook or the project Jupyter. You can just click here in project Jupyter. You can see three cases: Jupyter Lab, Jupyter Notebook, Jupyter Lite. Okay, Jupyter Lite, you can install Jupyter Lite, or you can use Jupyter Lab or Notebook. All the cases you can run the code. Okay, if you click on Jupyter Lab, directly this interface will be opened here. Okay, you just click on this, the new window, and after that you can see some notebooks are there. You have to click on this Python. After clicking on the Python, okay, this interface will be opened. Okay, now you can see this box. You can means code into this box only. Okay, you can write the code in this box, and after writing the code, this is the run button. You just click or shift enter, both cases you can use. Okay, so if your cursor is only this button, then you can run this, means only after means each and every box, or each and every box will be separately you have to run. So you write some code in here in this box, click on this run button. Okay, it will run. Okay, after that again another box will be opened. Okay, after running, if you want to use another box, you can code here. Okay, and you can run this code also. Okay, next one, this is one of the interface. Second interface, Anaconda. So Anaconda is also using same Jupyter. Anaconda, you have to download the Anaconda. Okay, so download Anaconda from here. Just you means click your put your email address and submit it, and then the downloading link will be opened, and you can just download the Anaconda. From Anaconda download, let me show you the interface of Anaconda, the Anaconda navigator. So all things it will work. Jupyter Notebook, Anaconda is also using the same thing. They're using a cloud. These are the cloud notebooks. Okay, no need to install. Jupyter you don't need to install. Jupyter Lite you can install, but a Jupyter Notebook or something, they're using the cloud platform. Okay, Anaconda it is a big software. It will just take time to open. Yes, this is the interface of Anaconda. So here you can see the Jupyter Lab, Jupyter Notebook is already there. So you just click on this launch and the Jupyter Notebook will be opened. Yes. This is the interface of the Jupyter. Also, you can see it's opened through the browser, but you can see that it can access our means own computers, own systems folders. You can see the folders, all these folders, downloads, desktop, and everything. It can access, which cannot be accessed through direct online platform. So better to use a Anaconda, download the Anaconda, which can access your own folders also inside your computers. Okay, so you can see all these things, and these are the things which I have prepared some files and I have saved here. All these saved file are in my computers, and that is why it can access everything. Okay, so if you want to access some Excel file, okay, without using the Anaconda and directly online platform you want to access, which is in your system, the Excel file is suppose in the download folders of your computer, your system, then maybe sometimes it may create some problem to access that file if you are using the direct online platform. So better you can use this Anaconda, and then through this Anaconda you use that to Jupyter, and it can be you can use it. Third one is VS Code. I prefer, okay, in my opinion, which is one of the best, Visual Studio Code. This one. Now here you need to download it. This is also you need to download this Visual Studio Code. Not only Python, all other kind of codings also you can run in Visual Code only. Okay, what you need to do, let me show you. So this is the Visual Studio Code interface, means website. Directly you can click on the download button. Okay, download for Windows. Okay, if you put it, just you can download it and install. After installing, what you need to do, now let me show my interface. Okay, so you can see this is the VS Code. After installation, you can see this kind of interface will be there almost, because I have written some codes here. So this will be updated after installing this. First, Python or any other code will not run here directly. you need to install the extension for that. And how can you find the extension? You can see this, the left hand side. Okay, the first one, it is Explorer, Search, okay, Source Control, Run and Debug, Extensions and Testing. Go to the extensions, and here you need to just which the program which you want to run. If you want to run R code, just use R extension. If you want to run Python code, just use Python extension. Okay, or Python. Now multiple means extension you can also install. So Python extension for a pack, we the Python debugger is there. Many Python extension are there. Okay, so just I think the Python extension itself, it can do the job. So you can just install this extension, Python extension, and run this Visual Studio Code accordingly. Okay, after using the Python, also you can install the Python debugger. So these two Python debugger, I suggest to install. So please write it down, and when the next day you come, please bring your laptop, and please means your this Visual Studio Code, install the Visual Studio Code with these two extensions, Python and Python debugger. Okay, there are many other extensions also, but we don't need this. Yes, also Py, this Pylance, you can also install this one. So Python debugger, Python and Pylance. Okay, no need to install any other things. Okay, now I want to means show you some. If you are coding in Python, you need to have some knowledge about some libraries. Okay, so the libraries which are mainly important libraries. Yes, data analysis and manipulations, the pandas, NumPy, SCIPy, Dask. Pandas and NumPy and SCIP, these three are very important. Okay, so I want you to please from the before the next class, you read that libraries at once, just at a glance. Pandas, NumPy, SCIPy, Matplotlib, Seaborn, and Plotly. Not any other cases. Other libraries I'm not suggesting. Just before coming to the next class, please just get an introduction, or just get a little bit knowledge about these libraries. So what kind of task, what kind of functions are there, which functions we will use, okay, which are actually included in these libraries. Please write it down, and after that I will winding up the session for today.
So we have a question that
Yes,
what are the softwares are used for linear regression? So do you suggest that this Python can be used or MATLAB can be used? Can you
linear
please?
regression, it's one of the prediction method. Okay, linear, not only there is no other software is, I don't think so any software. Yes, there are some online very small apps are there where the linear regressions, you just put the data set, it will give you the value of the linear regression. Okay, that small means apps are there in Google Play Store. You can also find it out, or in some softwares also, not software, some web pages are also there, websites are also there, some statistical website, they just putting the data set, they can give you the simple linear regression modeling and everything. Okay, just try Google, okay, and you can easily get it. Many software, many apps and many uh, means web pages are there where these kind of things are happening. Okay, but if you want to means make the means learn the entire prediction method, prediction modeling, Then you have to go for the Python or R or SSPS, MATLAB. These kind of things are there where all kinds of prediction models are there. You can use them.
Okay. So I have one question from my side. As per the discussion, today you have highlighted about the linear regression, right?
Yes,
So
yes.
for a layman, how a person should identify that should we go with the linear regression or the non-linear regression? So as a layman, how can we find out or predict which modeling should be preferable?
As a layman, I'm
Yes.
giving a very small example in Excel. I am just, if your dataset only you are using two datasets, X and Y, okay, for two dimension, then
Mhm.
okay, just draw scatter plot first. Okay, if I draw the scatter plot of this, you can see how the data sets are formed. Does it form a linear type of points? Means if I draw a line here, if I draw a line, does it support a straight line or not? Okay, are you getting my point? Let
Okay.
me discuss here only. Suppose our scatter plot is looking like this. You can see easily everyone can say, yes, if I draw a straight line in between them, okay, it should be the best fit line because it the trends is like a linear trend. Okay, but after
Okay.
plotting the points like this, if the points is this,
Hmm.
does it look like it is the straight line will be there?
Okay.
Of
Okay.
course not.
They are scattered
It
and
should
not.
be, yes. So
Yes.
for a
Okay.
layman, I'm asking just giving the example for a layman who don't know anything. Okay, there are many other things also.
Mhm.
Okay, so this is one of the case. Next case is auto correlation. Okay, X and Y data. If auto correlation, we can use it for multi-linear regression, not for the linear regression. Oh, sorry, simple linear regression. If independent variable is more than one, x1, x2, x3, and y. So x1 is x2, x3, they must be uncorrelated. There should not be any correlation between them. If there is correlation, then we cannot say that linear model will be the best fit. Third one is normality. X1, x2, and x3 must follow normal distribution. Okay, so for layman, this normal distribution and everything, these cases, it is new to them. So that is why I'm not describing all these things here. Okay, so normality is another condition. They follow x1, x2, x3 separately. They follow the normal distribution. This is another condition.
Okay.
Okay, so these are so for layman, I suggest that plot a scatter plotting here. Okay, if the scatter plot gives you the means the trend, you can understand like this for two
Okay.
dimension. But for three dimension, then to check it, this normality you need to check. Okay, auto correlation you need to check, and there is another condition also there. Okay, but for layman, I means that is in case of high dimensional data, it is difficult whether the data is linear or non-linear.
Okay.
Only after modeling you can say, if you compare different models, linear, non-linear models, or the ML, machine learning, and XAI, the means explainable artificial intelligence modelings are there. So if you use those modeling, then you can compare that which one is better model.
All right, sir. Got it. I hope we don't have any other question as of now, and the feedback link is also active. So, as you know, the conditions for achieving the certificate is to fill up the feedback form also. So, requesting all our participants, if you have any questions, so please drop down in the chat box, and you can so that you can interact with our experts and get acknowledged. And meanwhile, please do fill up the feedback form. And so we are waiting for any other question. I think, sir, you have already clarified the question that we have in between the session, actually. Um, yes. So thank you so much, sir, for your valuable time. And so tomorrow we'll have another session, 7:30, same timing, right? So we can continue from here, right?
Okay, so good night, everyone.
Good night, everyone. Thank you so much, sir. So, the good night, all our participants. And again, I'm reminding you that please do not forget to fill the feedback form before you leave the session. Thank you so much, and stay tuned to InnovaWorld. Thank you so much.